Let's now learn how to find maximum and minimum values of a function on a closed interval and then walk through some examples. The method used to find absolute maximum and minimum values of a continuous function that we'll call f on a closed interval from a to b is called the closed interval method. I have outlined what this method is. It has 4 steps that we need to follow. We first need to find the critical numbers, and then we need to check if each critical number is in the interval. Some will be, some won't be. Then we have to compute our function f at the critical numbers and also at the endpoints. And then our last step is we just have to compare these values that we found in step 3. Our largest value is our absolute max, and then our smallest value is our absolute min. I want to highlight one of the mistakes I see students make the most when they're doing the closed interval method. And that is, in step 3, it's so easy to substitute the critical numbers and the endpoints into f prime, but you don't want to do that. You want to make sure that you plug them in to f. Let's now walk through some examples. We are going to find absolute maximum and minimum values of our function on the given interval. Our first example is the function f of x is equal to x cubed minus 6x squared plus 9x plus 2, and then the closed interval that we're given is from -1 to 2. The first step in our closed interval method is to find the critical numbers. So we're going to start by taking the derivative. Our derivative is going to be 3x squared minus 12x plus 9, and we are going to set that equal to 0. We're going to need to factor this, but notice that there's a 3 common to each term, so let's go ahead and let's pull that out. So this is x squared minus 4x plus 3 is equal to 0, and we can factor this as, let's see, we can have an x minus 1 and then an x minus 3. We set x minus 1 equal to 0, and we get x is equal to 1, and then we set x minus 3 equal to 0, and we get x is equal to 3. X is equal to 1 and x is equal to 3 is a critical number. Our second step is to check if each of these critical numbers is in the interval from -1 to 2. X is equal to 1 is in the interval from -1 to 2, but x is equal to 3 is not in our interval from -1 to 2. Let's highlight this number because that is a number where we're going to potentially have a max or a min. Let's go to step 3. Step 3 says that we have to find the value of f at the critical number in the interval and at the endpoints. So we are going to find f at 1. You just go back up to the original function. Let me go ahead and highlight this in yellow. And we're going to substitute in that x is equal to 1. Notice that we are not substituting it in to that function. Up at the yellow, we have 1 cubed, so that's just 1 minus 6 plus 9 plus 2. Let's see, if we add up the positive terms, we have a 12. So this is 12 minus 6, and we get a value of 6. Let's highlight that because that's one of the numbers we're going to have to compare. Now we need to find our function at each endpoint. So let's compute f at -1. Looking back up to the yellow highlight, we have -1 cubed, so that's -1. And then we have -6, -9 plus 2. Let's see, we have a -10 minus 6, so that's -16 plus 2, gives us -14. That's a number that we have to compare. And now we have one more. Our other endpoint, which is at 2. So f at 2 is 2 cubed, which is 8, minus 6 times 2 squared, which is 4, plus 2 times 9, which is 18, plus 2. So let's see, this is 28 minus 24, so that is 4. Now our fourth step is to look at the 3 values that we got in step 3 and find the largest one and the smallest one. The largest value is 6, so we are going to say that we have an absolute max equal to 6 at the point x is equal to 1. And now let's look at our pink values and see the smallest one. The smallest one is minus 14, so we have an absolute min equal to minus 14 at x is equal to minus 1. And those are our answers to our problem. Before we move on, I want to show you what the graph of this function looks like. It's graphed over here on the right. Notice that when x is equal to -1, that's our left-hand endpoint, we have an absolute min. And then when x is equal to 1, that was one of our critical numbers, we have an absolute max. And you can see that the derivative is equal to 0 because we have a horizontal tangent. Let's now look at our second example. This one has trig in it, and I always think the trig ones are the hardest ones, so I wanted to make sure and include this. Our function, f of x, is x minus 2 cosine x, and then our interval is from 0 to 2 pi. Our first step is to find the critical numbers, so we're going to start by taking the derivative. F prime and x is 1 minus 2, and then the derivative of cosine is minus sine x. Let's rewrite this as 1 plus 2 sine x. And now to find the critical number, we're going to set that equal to 0. So this is 2 sine x is equal to minus 1. And this gives us sine x is minus 1/2. I went ahead over here on the right and drew a unit circle so that we can find the values of x where sine is equal to minus 1/2. Sine of x is going to be negative in this quadrant and in this quadrant. Sine you always associate with y, and this is our y. This guy is our x. So when y is minus 1/2, so that's like right here, so that's this point and this point. The point on the right is going to be x is equal to 2 pi minus pi over 6. You can always think about reference angles, and you know that sine of pi over 6 is equal to 1/2. And this gives us that x is equal to, let's see, 12 pi over 6 minus pi over 6. So this is just 11 pi over 6. And then over here in our third quadrant, x is equal to pi plus pi over 6. I have a video on reference angles if you need to brush up on that. And this gives us x is 7 pi over 6. Our second step is to check if these two values, this one and this one, are within our interval from 0 to 2 pi. Well, we picked them so that they were, so we actually don't have to do anything for this step. So let's just put that this step is done. So our critical numbers are 7 pi over 6 and 11 pi over 6. Our third step is to compute our function at the critical numbers and the endpoints. So we have 4 points to compute. Let's do the critical numbers first. F at 7 pi over 6 is 7 pi over 6 minus 2 cosine of 7 pi over 6. This is 7 pi over 6 minus 2, And then the cosine of 7 pi over 6, let's see, cosine is negative in the third quadrant. So we're going to have a minus root 3 over 2. So this is 7 pi over 6 plus root 3. And whenever you're doing a problem like this, we need to actually find the number because we have to figure out which are the largest numbers and the smallest numbers. So put this in your calculator and you end up with a value of 5.397. Let's highlight that in pink because that's one of the numbers we're going to have to check. Now let's do our other critical number. Let's find f at 11 pi over 6. So this is 11 pi over 6 minus 2 cosine 11 pi over 6. So this is 11 pi over 6. Hang with me. I know this is hard, but we can do this. Minus 2. Now let's think. 11 pi over 6 is in the fourth quadrant. Cosine is positive in the fourth quadrant. So this is a root 3 over 2. And this gives us 11 pi over 6 minus root 3. And this is approximately 4.028. And let's go ahead and highlight that. Now we're going to check the endpoints. These are actually easier. We have f at 0. So this is going to be 0 minus 2 cosine of 0. Cosine of 0 is 1. So this is just minus 2. That was a lot easier. Now we just have one more. F at 2 pi is going to be 2 pi minus 2 cosine 2 pi. So this is 2 pi minus 2. Put this in your calculator and you get a value of 4.283. And we'll highlight that. Now, we're almost done. Our fourth step is to look at all four of the values that we highlighted in pink and see which is the largest and the smallest. The largest is this one right here. So we can say that our absolute max is approximately 5.397 at 7 pi over 6. And then let's see our smallest value. Our smallest value is the only one that's negative, and that is negative 2. So our absolute min is equal to negative 2 at x is equal to 0. And those are our answers. Now, before we get done, I just wanted you to see the graph of this function. When x is equal to 0, we have an absolute min. And then when x is 7 pi over 6, we have an absolute max.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.